Hello, and welcome to another IoT Central webinar. I'm David O'Hara, and I'm the Managing Director at IoT Central. I'd like to start by thanking Quectel for sponsoring this event and Sony for being a part of the presentation. Today's webinar explains the advantages of cellular IoT platform integration with LPWA modules and the sub-GHz stack. Now I'd like to introduce today's speakers. Ohad Peled is the Product Marketing Manager at Sony. Tomas Pataros is the Product Manager at Quectel. Gentlemen, when you're ready, let's get started.
Hi, David. Great to be here today with you and with IoT Central. Today we'll be speaking about the integration of the sub-GHz stack into Altair 1350 based module, our BG950S-GL. Quectel has an extensive experience in working with the Sony platform. We have many modules developed based on Altair 1250. We have the full catalog of the full set of modules built of these modules on this platform. The BG950A, which is a CAT-M and NB-IoT module. The BG951A, which offers concurrent operations of WMB, wireless WAN, and GNSS. BG52 offering Quick Open. BG955 offering 2G fallback as well. And we have the BG953A, which is offering the integrated SIM. For size optimized applications or size sensitive applications, we have developed also the BG77 form factor, where we offer the CAT-M and NB module, the modules offering Quick Open, and module offering iSIM. We are also developing the variant which supports NTN based on the same platform. For the future, we are also working on a new module which will be presented later in the later slides. This module is the BG95S-GL based on Altair 1350. Ohad, would you tell us more about this platform?
Yes, of course. Thank you, Tomas. Thank you, David, too. It's great to be here. Pleasure to be here. And let's discuss about the 1350 with focus on the sub-GHz features, as Tomas just mentioned. Let's go through the platform first. The multi-standard sub-GHz is one very important feature of this platform, but actually the 1350, the ALT 1350, has a lot more features that are oriented towards IoT platforms or IoT devices in general. That's why we prefer to refer it as a platform rather than only a connectivity modem, essentially. So starting with the first and obvious, this is the third generation by Sony Semiconductor Israel of cellular IoT chipset, which means it's relying on tens of millions of units deployed already in the field and proven experience in that area. We've taken we decided to leverage this expertise and expand it also to new features. So in this specific platform, the current platform that would be the basis for the BG950S, it's going to contain a globally available modem. So essentially anywhere in the world should be supported by the 1350 hardware. It's going to contain more than one protocol, one standard for communication. We discussed, of course, the cellular IoT part of it, which is the major part of it, but also, as mentioned here, also sub-GHz and others. This will be the focus for today. It's designed for a secure operation. We have integrated a dedicated secure element within the platform and a separate integrated SIM, which we will support alongside the GSMA spec and 3GPP spec to support RSP eventually. So this will be supported. The MCU within the platform and the sensor hub are both designed to enable the device or the platform to implement some computational features on the device itself, so on edge, and reduce the load from the cloud. We've integrated other technologies that we see as fundamental in the IoT space for different use cases. Specifically, we have naturally the modems. We discussed the secure enclave and the iSIM that are part of any cellular IoT system in the coming years. We also have an integrated GNSS, which means you could get location fixes directly from the platform itself, and the MCU and sensor hub that we just mentioned to enhance the computational power of the system. This system also represents a huge leap in terms of low power consumption. So we started with a 1250, the previous generation, that was already very low in power, but we've managed to get it up to 8 times better in terms of power consumption for depending on the use case. So for use cases such as trackers and smart meters and some health devices and agriculture that require sending data in a few times a day, we're able to achieve very, very low power, and it enables tens of years on battery, again, all dependent on the actual application profile. Another important part here is the NTN, which we're supporting, again, since the 1250 platform already, but we would support this as well on the 1350 according to the spec. Okay, so the focus of today is the sub-GHz network and basically how they kind of play together with the cellular IoT space. This is really oriented towards smart cities type of use cases, so mainly stationary devices that are deployed in hundreds of thousands or million throughout a geographic region. And we see two main use cases to use the sub-GHz network on the same platform as the cellular IoT. The first one is acting as a low power gateway, so essentially using the ALT 1350 with a Quectel module would allow you to get the functionality of a gateway by using the sub-GHz networks, LPWA networks on one end, and using the cellular side to be the gateway to the actual cloud. Of course, that's not a full-blown gateway, so we call it a low-power gateway, and it's going to be also more cost-optimized than most gateways, and it would enable more flexibility in the construction of the network topology in general. The other use case is dual connectivity, which means for each end node, for each smart meter, for example, you could choose to implement or deploy two types of technologies and protocols within it. One would be a cellular IoT one, and the other would be the other sub-GHz network, such as wireless MBus or YSUN or other 15.4 based protocols. There are a lot of advantages in this one, and one of the main ones is fallback, essentially, and making sure that one protocol will always be available to communicate the data. This is especially important for mission critical applications that requires a high reliability, and in this case, whatever network fails to deliver, there's always a fallback of the other network. Let's go over a little bit on the benefits of using such a multi-protocol system. Of course, it requires more resources on the platform side, and the integration makes it much easier for devices to use different type of features within the platform. In this case, also the sub-GHz part. So the dual mode that we mentioned in the previous slide It allows you to use basically a single SKU to whatever you're deploying in the world, and wherever protocol you want to choose, maybe in different regions, you can use the same SKU for that. It increases the robustness of the system because of the fallback capability. So essentially, if you're not, you don't get the service you require on one protocol, you get it on the other one. It enables the use case of driving by, so essentially gathering data from whatever devices with just driving by them and collecting this type of data. It gives flexibility and easier deployment for network topologies that requires such protocols. One option would be for a device, if it's dual mode, it could decide already when deployed whether it's going to connect to one protocol or the other, and by that you're able to construct a network in a flexible way, right? So this is the flexible network topology side. Another example use case that combines the two, which I think is very interesting, is an example for firmware over-the-air support. So if you have like a bunch of meters, let's say, in a basement or in proximity of a sub-GHz network somewhere, you could get the firmware over-the-air file on one of them through cellular, and you can transmit all of that through the sub-GHz system. So the sub-GHz part here has the advantage that it does not have any connectivity costs associated with it, and you could easily and fast, you could deliver this file to all the rest of the meters in the area in proximity. Now, the other approach is a single mode device. The single mode still has both options available, even if it doesn't choose to use both protocols at the same time. So for this one, there's of course the single SKU management still, because you're going to use single SKU, whether you're going to use sub-GHz protocol or you're going to use the cellular IoT protocol. And it also provides you with the benefit of one SDK, one platform that you need to integrate your application on, and basically you could use whichever protocol you choose in order to do that. That saves a lot of engineering resources and integration resources, as you do not need to port your application per the communication protocol silicon, essentially. So going over the wireless MCU mode, as we call it on the ALP1350, we deliver within our platform the capability of a sub-GHz PHY. It's a low-level capability, and it allows us and our customers basically to support several types of protocols on top of it. So you could see here in the block diagram that we have the MCU and DSP that are responsible for running basically the protocol stacks and the PHY for the selected protocol. We have many years of knowledge in the RF space in general, and in IoT platform specifically. So we came up with this, basically leveraging this knowledge to create this wireless MCU subsystem that can enable short-range connectivity also for non-cellular LPWA protocols, essentially. At the same time with a cellular modem when needed. An example for those types of protocols are YSUN. This is 15.4 PHY-based protocol that can be supported. Wireless MBus, as will be presented by Quectel. It's also capable of supporting MIOTI, the new protocol, which we're looking into implementation, and any customer can choose to implement it, of course, with our support. And any proprietary protocol, there are many proprietary sub-GHz protocols out there that are relatively simple and requires essentially a layer that would enable them to communicate with the PHY and the RF, and this is what we're providing with our MCU, wireless MCU mode.
Thank you, Ohad. Now I will actually speak about our module more in detail, the BG950S-GL, based on the Altar 1350, and we'll see now how we benefit out of technology developed by Sony in bringing you a very interesting product to the market. As we said, the first benefit of, let's say, of this module is actually extremely low power consumption. This power consumption enables our customers to deploy products which will be, the battery consumption will be much, much lower, so this will enable up to 8 times longer battery life. The next point, which is very important, is the possibility of integrating the short-range connectivity. As we have seen, we heard today, Wi-SUN, MIoT, WBus, and also any kind of proprietary protocols. It will offer GNSS and Wi-Fi positioning. And what is, let's say, very important and interesting feature our customers are looking for is the iSIM carrier-grade certified, GSMA certified, and supporting the, let's say, remote SIM provisioning according to SGP32. So on top of it, it will also allow our customers to connect over satellites through band S and band L. The timeline for this module is, let's say, engineering samples are already available. These are, let's say, for development purposes. Later in beginning of Q3, we will have available commercial samples. This means that our customers already be able to test the module and to start the early development. And the mass production of the module is planned to be by the end of this year. Applications with WMBus. Ohad already mentioned, let's say, the single mode and dual mode use, and we see the same demand from the market. With WMBus, we can actually allow our customers to develop gateways for remote meter reading, actually by replacing the drive-by or walk-by application mode nowadays. And also to use the device as a gateway to control through a specific meter or other device, also home appliances. So we could use as the devices remote sensor management reading, remote meter reading, or gateway to home application, as we said, and once we have collected all the data, also manage properly the power consumption and energy consumption. How will it happen? We see that there are many different variants of WMBus stacks, so we would like to allow our customers, which are already on the market, to use their own WMBus stack. So we will allow our customers to integrate the protocol stack or the WMBus stack directly in the module based on the hardware abstraction layer, which will offer all the needed resources to integrate the WMBus stack. The WMBus stack then, once finalized, will be flashed by the customer during the end product production. But there are also many customers who don't have today WMBus, and so we will pre-integrate, pre-license also stack, and will allow our customers to finalize and to customize this software. Again, because this may be different from customer to customers, the customer also have the option to flash it during production. Our support will come from our R&D center in Belgrade. What are the main application scenarios and market? So of course, we have seen public utilities in water and gas metering, smart parkings, fire hydrants, smoke detectors, street lighting, smart dust bins, but also in smart life and wearables as asset tracking, wearable devices, personal pet tracker. There is also an option of in the industry and agriculture with gas detector, soil pH and optical sensor, machine alarms, irrigation controllers. So very, very wide possibility of application for this module with the integrated W bus or other sub-GHz stacks. So David, thank you for having us today. And it was a pleasure to talk about the Altair 1350 and the BG95S together with OHAT. Thank you for the opportunity.
Thanks, gentlemen. This brings our webinar to a close. I'd like to thank OHAT and Tomas for their insights, and thank you to Quectel for sponsoring today's event. You can view more webinars, including the previous edition with Sony and Quectel, at iotcentral.io. Thanks for watching.